Hey guys, it's Boniface. I'm going to go ahead and go over with you guys a little bit how to predict the products. Okay, and the reason I'm doing this on video is because sometimes it's nice. As you work through this, you'll also be completing a pair deck. I'll give you some of the answers here, other ones you have to finish it yourself. I would recommend kind of have two, like both screens there. Maybe watch the video points, and then when I ask you to go try things yourself, go ahead and try them yourself in the pair deck and just kind of see how that plays out. Okay, so we're going to skip. So predicting the product. So it's using our, one second here on it. So it's using, it's our understanding of the types of reactions to predict what products a reaction would form. So basically, when looking at a reaction, let's go see if I can go here to the next slide here. Okay, how this thing works here. So like here on this one here, I'm going to be giving you the left side, and you're going to need to predict the right. Okay, and that's kind of what. So some brief walkthroughs on synthesis reactions type we'll be doing here. I'll give you individual elements, and you need to combine them. It'll generally be swap and drop. Okay, matching the charges. Okay. Over here, in this case here in decomposition, you'll see just one element. Sorry, one compound, not one element. There'll be one thing on the left side, one compound, and you won't see this right side, right? But what you're going to do is you're going to go ahead and break it up into its pieces, okay? So there's some other options, but that's more like the extra credit-y type of thing, okay? We aren't going to worry as much about that. So if you see H2O here, well, you have to put H by itself and O by itself, but O can't be by itself. It's one of the seven. So remember, there's 7 elements that are diatomic is what it's called, but they just can't be by themselves. On single displacement, I'll show you how this works a little bit later. So the metal takes the metal spot, and if you're non-metal, you take the non-metal spot. And then, so you know that Mg and Cl will be together. You need to look up their charges. So you pull out your periodic table. I have mine right here, and I know that Mg is a 2+ and Cl is a single minus, and I would swap and drop them until they work out right. Fe is by itself, that's fine. Same deal down here, okay? Now what makes this one a little bit more challenging is you need to figure out the charge of that Fe, and you kind of have to work backwards. So you'd work backwards to figure out the charge of the Fe, and then once you do the charge of the Fe, you can swap and drop it with Br. You know how many. We'll see some examples later. Okay. Double displacement, kind of the same deal here. Na is with Cl, so they're going to swap partner spots. Na is here, so to swap into the spot here, Mg is there, and that way, so Mg is going to end up with Cl, and you'd swap and drop. You look up Mg's 2+ and Cl single minus, and you swap and drop it to get to Cl2, and Na is going to go with Br, so you'd end up with NaBr, and Na is a single plus, and Br is a single minus. Again, use your periodic table. Okay, use your periodic table to figure out the charges, and that would help you work out there. Okay. Same deal here, Pb and NO2. So Pb can either be a 2+ or a 4+. You need to figure out which one it is by looking at the charge of NO3. You have 2 of them. When you look at NO3, you see each one's a single negative, and you kind of work backwards. So basically swapping. So Pb is going to go here, but you have to figure out the charge of the Pb to make that all work out. We'll see some examples. It'll make more sense. Okay. Combustion, one of the easiest and trickiest. Okay. So again, you won't see this right side, but you'll always see something with CH, sometimes O's in there too, but it always reacts with oxygen. And what makes it super easy is it always makes CO2 and H2O. Okay. This is the entirety of your notes. So please pause this video and write down all of this. This is the pattern you're going to use. In decomposition, remember these are symbolic of different elements. So A and B are like 2 elements together, right? And what you're going to see and what you're going to do is you're just going to write them apart for the other side. If it's combustion, you'll have something of CHs and oxygen, and what it will make will always be CO2 and H2O. Double displacement here, notice they're swapping spots, whatever A, so you end up with A and Y, and you end up with X in front of B. So you can kind of see these are symbolic letters, okay? So single displacement, kind of the same way. I would remind you that the Y could either end up in the A spot or the X spot, depending on metal or non-metal. And synthesis, you just take things and combine it. So you have to think about which one it looks like, okay? So these ones are actually, so now it asks you here to go ahead and find out what are the type of each of these reactions, okay? I'd ask you to pause this video right here in the pair deck, go through this part here, and do a little mental test to figure out what type each one is, okay, to make sure you feel comfortable. Okay, pause. Okay, so I assume you went through all those, okay, and you feel pretty good about that. This is, again, the notes that you had to do. Now we're getting to real ones that are actually like the ones we're going to have to do. Okay, so here's the first one, okay? I want to highlight a couple things here. It is Al plus O2. Notice they are both single elements, okay? So we go back to this chart here. 1 second. The circles will be there temporarily. I'll erase them in a second. Which one of those look like single elements, okay? Which one look like single elements? So it looks like these two are single elements, so you're going to put them together, okay? It's synthesis. I apologize, they're out of order here. It just ended up that way. Okay, so 2 single elements. So I'm going to combine Al and O2. So I go look up on my periodic table, and I find out that Al is a 3 plus and O2 is a 2 minus. So when I swap and drop them, I need to think about how many of each one, or balance the charges, whichever way that works for you, right? You think about the balance, right? How many of each one? Well, the common number between 3 and 2 is 6. So you need 2 3 pluses, and you need 3 2 negatives, okay? So in this way, the answer is going to end up with, since you said it was synthesis, it's going to come together at Al2O3. That's the answer, okay? Then we normally, like on the quiz, we balance this thing, okay? So you swap and drop the charges, and that's what I mean. The 2 goes down here, and that goes so in that way. Okay, so hopefully that helps. Okay, I'm gonna go ahead and erase this. Give me a second. Blah 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 blah. Erased. Okay, cool. Let's go on to the next one. Okay, this next one here. Notice that there's something with a partner and something by itself. So as your mental state, which one is it? Think for yourself. And if you said single displacement, you're wrong. So this is one of the ones that tricks people. So if you look here, you're right. It does look a lot like single displacement, but notice it is a CH something and an O right there separately. So that means it is going to be combustion right here. It's going to be combustion. So CH and then O, which makes it the world's easiest problem because anything is combustion is always, it doesn't matter the order, H2O plus CO2. I mean, you can do it the other way around, CO2 plus H2O. Boom, there you go. And then you balance it. So you aren't going to have to do that today, but in the future, you'll have to balance them, okay? Expect to be able to do that on a quiz or test, okay? So I'll go ahead and clear that. Okay, so back to this one here. Okay, so next one here. Okay, so this one's going to be a little bit more challenging, okay? Notice they both have partners. Think about which one that might be. Okay, hopefully you thought double displacement, okay? Which means that Li is going to end up with SO4 and that Cu is going to end with Cl. So let's do the Li first. Li is, I'll just write down here, Li is a plus. I need to look at my ion sheet, which I should have gotten that before. Dig around my pile here. SO4. I think it's 2 negative, but I'm not positive. SO4. Is that 2 negative? Yep, it is 2 negative. SO4 is 2 negative. So now you're going to swap and drop them. How many LIs you need to balance that one? If you thought 2 LIs, it's going to be Li 2 SO4. That's right. Okay, there's U plus, and we need to put CuCl. Now the Cl is really easy. You look that up on your periodic table. It's in the far, sorry, this way, mirrored, far right, and it's going to be a single negative. Okay. Now Cu, when you look it up on here, you'll see it could be either a plus or a 2 plus. So which one is it? Well, the way you figure it out is you look over here, right? So there's one SO4 for one Cu, and it's neutral. So if this is 2 negative, that means that Cu must be 2 positive. Remember, these are balanced out here. Okay. So we have now we know what Cu's charge is because this was 2 negative. So this has to be 2 positive to balance it out. So now we have a 2 positive and a single negative. So it should be Cu, just one of them. And you need 2 Cl's to go of it. Cl2. And that's what that was. Hopefully that helps. We're going to continue doing more practice problems like that. Clear all drawing here. Okay. Okay, let's do the next one. NaClF2. So think about whichever that one could be. Go back to your chart over here. Think about the ones in your notes. And you'll notice here that Na and Cl have a partner and this one doesn't. So it's going to be single displacement. The question is, does it go in this spot or this spot? Whose spot does F take? The key is F a metal or non-metal? Or in other words, is F a negative or a positive? When you look up F on your periodic table, you'll see that it's a non-metal and it's negative. So it's going to take the spot of the non-metal that's negative. Okay. So in this case here, Na is going to end up with F. The question is how many of each? So when you look up on your periodic table, the charge for Na, right? Charge for Na is going to be positive, and the charge for F, and it's just one F, like you only look at each one individually, is single negative. So it's actually just going to be one Na, one F. And then if you plus Cl by itself, and if you put that down, you're still wrong. Think about what could be the mistake. Cl has to be a 2. It's one of those 7 that can't be by itself. That's how that works. And that's hopefully you're starting to get the hang of this a little bit. Okay, let's go on to the next one here. So here are our answers, and you can kind of see how they are, and in that way. Please go ahead and fill this out in your Pear Deck if you haven't done that yet, because this is in your Pear Deck. Go ahead and fill this out in your Pear Deck. Pause the video. Fill this out in the Pear Deck. So now here's our final set, and we're going to do another set of these like this, and I'll just kind of walk through them too. Before we do it, you try these yourself first. It is okay to be wrong, okay? When typing them in, feel free, because it's hard to get the 2 down below perfectly, right, or whatever else. Feel free just to put a big 2 when typing it in or anything else like that. The key is that you're doing the thinking, okay? Remember, they aren't balanced until we balance them, but I'm not going to make you do that today. I want you to mostly worry about predicting the products, okay? So this one here, I'll just kind of go over each one. Pause, do them all, or you can do one at a time if you want to do it that way, right? But I want you to try these first, okay? So Na is with Cl, right? So they're both individual elements. So this one is going to be synthesis, 2 inlets. So you want to put one Na or one Cl. When you look at the charge, this is a plus, this is a minus. So it's just going to end up being NaCl. Okay. Go to the next one. Okay, MgF. Okay. So this is a single element. This is something partnered, okay? So in this way here, it's single displacement. Mg is going to either come in this spot or it's going to come in this spot. You should think about where it goes. This is going to go in the spot, okay, where the metal is. So this right here is a metal, so it's going to take the metal spot, okay? In this way, metal into metal, okay? So you're going to end up with Mg with Cl, okay? Mg with the Cl. And then you'll have Fe by itself. Okay. The question is, how many Cl's are there? So you look up Mg and it's a 2 plus, and you look up Cl, it's a minus. So you think about how many to balance each one. You'd need 2 Cl's that are negative to balance that one up. So that's how that works. Okay. So another single displacement one here, notice. This is here, this will go either there or there. Question is where, right? Well, so this is negative, it'll take the other one that's negative spot, or the non-metal to the non-metal spot, okay? So in that way, you're gonna end up with Fe with Br, and then Cl by itself. Now there's a couple things that need to be fixed here, okay? Let's do the easy one first. Cl can't be by itself, so it's Cl2. Okay. Now, the hard thing is figuring out how many Brs. Now, to figure out how many Brs are, you need to figure out the charge on Fe. Br itself is negative when you look it up. Now, how do you figure out this one? Well, you have to figure out the total amount of negative in this ion. So you look up Cl, and each Cl is negative. So you have negative, 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 3 negative right there. So this has to be a 3 positive. So you're going to cross a 3 positive with a single negative, so you need 3 Brs. Hopefully that helps. Okay, NaCl plus MgBr. Okay, this one is pretty easy to identify as a double displacement. Okay, in this case here, you'll notice that they both have partners. So you're going to go ahead and swap those partners. So you're going to end up with something that's Na with a Br. And then you also have something that's Mg with a Cl. You just need to figure out how much of each. So this is a positive on the periodic table. This is a negative. This is a negative. This is a 2 plus. So now you have to swap and drop. So it's 2 positive with single negative. So you're going to need 2 Cls to balance out that 2 plus for the Mg. These are both single, so that's great. So that one's done. Okay, this one here is also not super bad here. Sorry, this is a little more challenging. You may have, if you pay close attention to the problems, you may have noticed something, which is good eye for you. But keep paying attention because we're learning the mechanism, because I'm going to start throwing a bunch of stuff at you tomorrow. Okay, so that's the key there. Okay, so here we go. First with PB. And since it's double displacement, these two need to go together. And then these two will go together, right? So we have PB, and that's a horrible B, PB. The question is, how many SO4s do we need? Well, to do that, we need to figure out the charge of PB. So NO3, when you look it up, is a minus. So that means if there's 2 NO3s, what's PB's charge? Well, it has to be a 2 plus to balance it out. So PB is a 2 plus. SO4, when you look it up on your ion sheet, is a 2 minus, so it's just PbSO4, one of each. Okay. Na, when you look it up, is plus, and each NO3 is single minus, so it's 1 plus, 1 minus, so it's just Na with a NO3. And that's how that works. Okay, did I just do that one? Oh yeah, we did that. You don't have to do it twice. Oops, I'll delete that slide. Okay, this one here. So you have single partner, something by itself. Don't get tricked. Hopefully you thought it was combustion because it's a CH thing and this is O2, which means it's always going to be CO2 plus H2O. Super easy. Yay, CO2 plus H2O. Amazing. We're super science geniuses. Yay. Okay. So the key is just identifying that it is that. 1 second, I'm trying to erase all my stuff. Clear all. Okay. There you go. Okay. So we did that one. And here's all of those answers. Okay. And you may recognize them. There were some practice problems we did before again. Now, normally I would then have you balance them, but I'm not going to have you do that this year on this set of problems because we only have a certain amount of time. So get the pair deck complete with all your answers typed in, get that submitted or completed, and it'll give you the full points. So thanks.